Hello guys, in this video we will learn about finding out distance between 2 points whose Cartesian coordinates are known. Let us have coordinate axis and a point P located at coordinates x1, y1 and another point Q whose coordinates are x2, y2. Now we need to find distance between these 2 points. Let us construct we have drawn perpendicular from point Q to y-axis and x-axis, and similarly we have drawn perpendiculars from point P to y and x-axis, and we can see that a right angle triangle is formed here with this coordinate. Let us say this point be R. Now this length this length is y2 and this length is y1. Similarly, this length is x2 and this length is x1. Now we see here that the length of the side of this triangle QR of the triangle PQR is y2 minus y1, and the length of side PR is x2 minus x1. Now if we apply Pythagoras theorem in this triangle, we get PQ square equal to PR square plus QR square. Further, PR, which is our x2 minus x1, x2 minus x1 square plus y2 minus y1 square, where PQ is the distance between the 2 points. Let's call it D. So this will be D square, or D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is called the distance formula, and this formula is used when we have to find distance between 2 points whose Cartesian coordinates are known to us. So summarize again, for the point P whose Cartesian coordinates are x1, y1, and Q whose Cartesian coordinates are x2, y2, the distance between the points PQ is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now using this formula, let us solve a question. Find distance between point A whose coordinates are 3, 2 and B whose coordinates are 2, 3. Uh, Solution. Pause the video, solve the equation and then resume the video to see the answer. I'm going to solve it here. A is 3, 2. B is 2, 3. This is x1, this is y1, this is x2, this is y2. Then we have AB is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So to be x2 is 2 minus x1 is 3 whole square plus x y2 is 3 minus y1 is 2 whole square. Comes out to be 2 minus 3, which is minus 1 square plus 1 square, which comes out to be square root of 2, or which is approximately equal to 1.41. This is the length of AB, distance between A and B. Another question. Find distance between point P 3, 2 and point Q minus 2, minus 3. Again, pause the video, try this for yourself, and then look up to the solution that follows now. Remember that the values of all the coordinates are entered in this formula with their algebraic sign. X2 is minus 2, by x1 is minus x1 is 2 square plus y2 is minus 3 minus y1 is 3, which is further equal to minus 4 square plus minus 6 square, which is further equal to 16 plus 36, which comes out to be square root 52 and approximately equal to 7.21. Let's try another question. Show that points 1, 7, 4, 2, -1, and -4, 4 are vertices of a square. Solution. See, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5. So let us first look at these points here. 1 and 7. This point will be somewhere around here. Let's say this is the point A. 4, 2, somewhere around here. So this is point B. Point C, -1, -1, somewhere here. Let this be point C. And point D, -4, 4, somewhere here. So if we join, these points, we have a square. Means points A, B, C, and D are vertices of square, and we have to prove it. For proving this to be a square, we have to prove two things. One, all sides are equal, and both diagonals are also equal. If we prove these 2 points pertaining to the vertices of these A, B, C, and D, then we will establish that A, B, C, D are vertices of a square. So I have told you how we will approach the problem. You should pause the video and try the question yourself and then see the answer by resuming the video. What we will do, we will evaluate lengths of all the sides AB, BC, CD, and AD, and we will establish that all these sides are of equal length. Then we will establish by proving that the diagonals BD and AC are also of equal length. So let us start proceeding with the question. Let point A, x1, y1 is equal to A 1, 7. Point B, x2, y2 b b 4, 2. Point C, say x3, y3 b c -1, -1. In point D, x4, y4 into D -4, 4. Now let us first find AB is equal to x2 minus x1 whole square. X2 is 4 x1 is 1 plus y2 minus y1. y2 is 2, y1 is 7 whole square. It comes out to be 3 square plus minus 5 square. It comes out to be 9 plus 25. Comes out to be square root of 34. This implies that AB is equal to square root of 34. Now, point BC is equal to x3 minus x2 whole square plus y3 minus y2 whole square, right? x3 which is minus 1 minus x2 which is 4 whole square plus y3 which is again minus 1 y2 which is 2 whole square, which comes out to be square root of minus 5 whole square plus minus 3 whole square, which comes out to be square root of 25 plus 9 square root of 34. This implies that BC is also equal to square root of 34. Now let us calculate the length of the side CD. CD will be given by x4 minus x3 whole square plus y4 minus y3 whole square. X4 which is minus 4 minus y x3 which is minus 1 plus y4 which is 4 minus y3 which is minus 1 is equal to minus 4 plus 1 whole square plus 4 plus 1 whole square, which is equal to minus 3 whole square plus 5 square, which is equal to 9 plus 25. Therefore, length of the line segment CD is equal to 34. Now, let us evaluate the length of the side AD, which will be given by x4 minus x1 whole square plus y4 minus y1 whole square is equal to x4 minus x1. x4 will be minus 4, x1 will be 1 whole square plus y4 will be 4 minus y1 will be 7. which will further be equal to, this will be minus 4 minus 1 minus 5 square, which will be 25, plus 4 minus 7 will be minus 3, square will be equal to 9. Therefore, AD is equal to square root of 34. So up to here, we have established that AB is equal to BC equal to CD is equal to AD. This implies that we have already proven that the given figure whose vertices are A, B, C and D, this figure is a rhombus. We have proved that. And now, to prove that it is a square, we have to establish one more fact, that its diagonals are equal. That is, we have to check whether AC is equal to BD. So now let's start by finding the length of diagonal AC. AC is equal to x3 minus x1 whole square plus y3 minus y1 whole square is equal to x3, which is equal to minus 1, x1, which is equal to 1 minus 1 whole square plus y3, which is equal to minus 1, and y1, which is equal to 7 whole square. This is equal to minus 1 is equal to minus 2 square is equal to 4, plus minus 7 minus 1 is equal to minus 8, its square is equal to 64, is equal to square root of 68. This implies that AC is equal to square root of 68. Now let us evaluate the length of diagonal BD. It is equal to x4 minus x2 whole square plus y4 minus y2 whole square, which is equal to x4 is equal to minus 4, x2 is equal to 4, it will be minus 4, plus y4 will be equal to 4 minus y2 will be equal to 2 whole square, which is equal to minus 4 is equal to minus 8 square is equal to 64, plus 4 minus 2 is equal to 2, its square is equal to 4. Therefore, we get diagonal BD is equal to square root of 68. Therefore, we have also established that AC is equal to BD. Therefore, the quadrilateral formed by the vertices A, B, C and D is a square. The next concept which we will study, which requires the application of distance formula, is collinearity of points. So we have considered, say we have 3 points, A, point B and point C. The 3 points A, B and C, or any number of points, are said to be collinear when a line can be drawn such that all these points lie on the same line. Means all these points lie the same line, then it can be said the points A, B, and C are collinear points. So if these points can be drawn on a straight line like this, means there has to be a relation of distance between them such that distance between A and B plus distance between B and C must be equal to distance between A and C, right? So for collinearity of points, this condition is very essential that AB plus BC is equal to AC. Now with this understanding, try to solve this question. Pause the video, try the question yourself, and then resume the video to see the solution. Prove that points 3, 1, 6, 4, and 8, 6 are collinear. Solution. Let us name these points. Point A be called 3, 1. Point B say 6, 4. And point C be 8, 6. Now we have AB is equal to square root of x2 minus x1. x2 is 6, x1 is 3. 6 minus 3 whole square plus y2 minus y1. 4 minus 1 is equal to square root of 6 minus 3 is 3. Its square is 9 plus 4 minus 7 is 3. Its square is again 9. So AB is equal to square root of 18, or we can say 3 root 2. Let us see how we have arrived to this 3 root 2. It can be written as, we can prime factorize 18 as 3 into 3 into 2, or square root of 3 square into 2. Since square root of 3 square is, we can further write it down as 3 square into square root of 2, or 3 root 2. So we have AB is equal to 3 root 2. Result number 1. Now we have BC is equal to x3 minus x2 whole square. X3 is 8 minus x2 which is 6 whole square plus y3 minus y2 which is 6 minus 4 whole square, which is equal to 8 minus 6 is 2, its square is 4, plus 6 minus 4 is 2, again its square will be 4. BC will be equal to square root of 4 plus 4, which is 8. We can further write it down. BC is equals to 2 square root of 2, because it is called, and further be simplified as 2 root 2. Similar fashion, we prime factorize 8 and then we arrive to this figure. So BC is equal to 2 square root of 2. This is result number 2. Now let us calculate the length of AC, which is equal to x3 minus x1 whole square. X3 is 8 minus x1, which is 3 whole square, plus y3 minus y1 whole square, 6 minus 1 whole square, comes out to be 8 minus 3, 5 square, 25, plus 6 minus 1, 5, it's a square, 25 again. It is equal to, either we can write it down as root 50, or we can also write it down as 2 into 25, which can be written as square root of 2 into 5 square. This 5 square will be coming out of square root sign as 5, and this root 2 will remain like this. So AC is equal to 5 root 2. Result number 3. Now we found AB to be, AB was 3 root 2, BC was 2 root 2. So AB plus BC is equal to 3 root 2 plus 2 root 2 is equal to 5 root 2, right? Now since AB plus BC equal to 5 root 2 and AC is also equal to 5 root 2, then we can say that AB plus BC is equal to AC. Therefore, with this conclusion, we have established that A, B, and C are collinear points. Now let us look at another very beautiful question. So the question is that you have to find a relation between x and y such that the point represented by x comma y ordered pair in the Cartesian coordinates will be always equidistant from points 7 comma 1 and 3 comma 5. A point which is represented by x comma y, and that point will be equidistant from 7 comma 1 and 3 comma 5. We have to find such relation in x and y. Again, pause the video, try the solution, and then see the answer. Let us point px comma y, point AB 7 comma 1, point BB 3 comma 5. Then what we require is that AP is equal to BP, or we can say that AP square is equal to BP square. Now AP square is um, x minus 7 whole square plus y minus 1 whole square is equal to BP x minus 3 whole square plus y minus 5 whole square. I have squared these terms in this previous step so as to remove the square root sign in the distance formula. So now let's expand these brackets. We have x square minus 14x plus 49 plus y square minus 2y plus 1 equal to x square minus 6x plus 9 plus y square minus 10y plus 25. Solving this equation further, let us simplify LHS and RHS separately. We have 49 plus 1, 50. This x square will be cancelled out with this x square. This y square will be cancelled out with this y square. So we will have 50 minus 14x minus 2y is equal to 9 plus 25 will be 34 minus 6x minus 10y. We will solve it further. 50 minus 34, 34 taken in the left hand side. 50 minus 34 equal to, all these terms x of x and y are taken on the right hand side. 14x minus 6x minus 2y plus 2y minus 10y. This will be equal to 16 is equal to 14 minus 6, which is 8. 8x minus 10 plus 2, which is minus 8y. Or we can further write it down as x minus y is equal to 2. So if we have this relation between x and y, then the point represented by x comma y will be equidistant from 7 comma 1 and 3 comma 5. Such let us find out a few of such coordinates. For example, for x equal to 1, we have y equal to uh, for x equal to 1, we have y equal to x minus 2, or this implies that y is equal to 1 minus 2 equal to minus 1. So the point 1 comma minus 1 will be equidistant from 7 comma 1 and 3 comma 5, that is point A and B. If P is equal to 1 comma minus 1, then this P will be equidistant from the points A and B. You can practically find out by putting these values in the distance formulas and then comparing the values of AP and BP. Similarly, we can find another such point. For x equal to 2, we have y equal to x minus 2 implies that y is equal to 2 minus 2 equal to 0. So for another point q, which is equal to 2 comma 0, we can further say that this point q is equidistant from point a and b. You can again put the values in the formulas and find out the answer. Now let us look at one more question, and up to the concepts which we have studied so far and the questions you have practiced, it is highly recommended that you solve this question yourself. I will be providing the solution here, but you pause the video, try this question yourself, and you must be able to answer it. The question is, find a point on y-axis which is equidistant from points 6, 5 and -4, 3. Pause the video, give it a try, and you should be able to solve it. Now let us say the point on the y-axis be 0, y. Since the point is on y-axis, we can conveniently say that the axis of the point will obviously be 0. Hence, we take the point to be 0, y. Let the point A be 6, 5 and the point B be -4, 3. Now, AP is equal to BP as far as the modeling of the question is concerned. Again, to remove the square root sign in the subsequent step, we shall conveniently multiply, we can conveniently square the equation both the sides. AP square is equal to BP square. So AP square will be 0 minus 6 whole square plus y minus 5 whole square is equal to 0 minus 4 whole square plus y minus 3 whole square. Now solving this equation further, this comes out to be 36 plus y square minus 10y plus 25 equals minus into minus will be plus 0 plus 4 will be 4. 4 square will be 16 plus y square minus 6y plus 9. This y square to this y square will get cancelled. It is 36 plus 25. We will take this 10y to the right hand side. 16 plus 10 will be 25 plus 10y minus 6y. This 25 will get cancelled with this 25. So we have 10 minus 6, 4y. 4y equal to 36 or y equal to 9. So the coordinate on y-axis, which is equidistant from the points A and B, coordinate P 0, y is equal to p 0 comma 9. This is our required answer. That's all for this video. In the next video, we shall be learning about section formula. Till then, have a great day. See you all soon.